Assalamualaikum warahmatullahi wabarakatuh everyone. This is a pre-recorded lecture for week 10 titled Techniques in Biochemical Analysis. So in this chapter, we will continue focus on chromatography principles and techniques that have about 7 techniques and we already done on the paper chromatography, thin layer and also thin layer chromatography. So today we focus on high HPLC technique, GC, size exclusion chromatography SEC, ion exchange chromatography, okay, and affinity chromatography. Okay, other than chromatography technique, okay, to analyze our sample we can use spectrophotometer, which the spectrophotometer it will follow the Beer's law. Okay, the machine okay follow the Beer's law. Okay, in chromatography, high performance liquid chromatography, you can tahulah what is the mobile phases and also the stationary phases. Okay, that is the basic thing in chromatography technique. So in HPLC, okay, the mobile phases adalah solvent yang kita gunalah. Kita akan prepare different types of solvent. Okay, yang mana kita akan letak dalam these bottles, which will be our mobile phase. Okay, and it also for the stationary phase adalah column mana ada dalam inside this machine lah, which is our stationary phase. And this is HPLC usually used okay to identify okay the compound or analyte, ANALYTE, analyte concentration yang ada pada at very minimum concentration. Okay, so this is very high very specific machine di mana boleh identify very small amount of compound pada you punya sample extract. So this is a very good very good chromatography technique in analyzing your samples. So HPLC usually the mobile phases, the solvent yang kita guna tadi adalah usually the polar liquid. Okay, and this polar liquid or the mobile phases, okay, the solvent tadi dia akan dipump okay pergi ke column, which is the stationary phase. So this injector okay is the component that will inject your samples or your extract tadi ke dalam column. So you letak you punya sample dalam near to the injector. So the injector dia akan inject your samples okay ke dalam column. So the function of the solvent tadi, which is the mobile phase, dia akan tolak your samples okay by the pressure of the pump tadi along the column. So then okay the detector will detect okay the presence of your compounds okay inside the extract. So the waste here will collect okay, then waste here dia akan collect the mobile phases yang melalui kolom tadi dan juga the you punya sample extract. So what being detect or what inside the column, especially the compound ataupun analyte tadi, it will be recorded pada chromatogram. So HPLC used to separate components yang mana tak sesuai pada GC. What is GC? GC is gas chromatography. So because GC ni usually it analyze compound that is volatile, okay, mana dia boleh meruap. Okay, so sample yang tak sesuai pada GC, you can use this HPLC. Dan HPLC is very good because it can identify presence of very small quantities okay inside your sample. Okay, so this is HPLC system, the mobile phases okay, which is the solvent. Dia akan melalui the pump again okay, dia ada injector, dia akan inject your samples okay, then melalui HPLC column, detect by detector the presence of compound, and then the waste of the mobile phases and the data okay, dia akan show the presence of your compounds and then pada chromatogram tu nanti kita akan nampak graph lah yang mana ada you punya presence of compound, dia ada peak area, tunjuklah this is the compound yang presence at retention time ke berapa. So this is the first compound. Daripada retention time yang kedua ada lagi another compound, so the second compound. So the presence of compound ni identify based on the presence of the peak area, okay, the peak okay pada graph. So the compound ataupun the analyte ni dia akan melalui the column which is the stationary phase, yang mana dia akan dibantu oleh liquid which is the solvent tadi. The solvent tadi adalah mobile phase dan dia akan ditolak by high pressure by pump tadi yang produce the pressure. So the advantage of using HPLC is that increase the speed of measuring your samples, higher resolution, very sensitive, better recovery and better reproducibility. Next is GC or gas chromatography. This you measure the volatile compound and this is the column. Kalau compare dengan column tadi pada HPLC dia memanjang kan. However GC dia lingkaran. Okay. So dia sesuai untuk measure samples yang volatile and juga sampel yang non-polar. Okay. What you have to know about every chromatography, kena tahu dia punya mobile phases. So the mobile phases will be the bukan soal liquid solvent, tapi dia punya mobile phase adalah gas. Dan dia ada injection port bagi yang akan inject your analyte. Okay, dan dia juga ada column yang bentuk macam tadi. Column ni adalah the GC column. Okay, dan dia juga ada detector to detect the presence of analyte inside your samples. Okay, and the mobile phases yang usually guna adalah the inert gases. Okay, again mobile phases for GC adalah gas. So the inert gases such as the helium, argon and nitrogen. Dia ada injection port. So injection port dia consists of a rubber septum. Okay, di mana you akan inject your samples. Okay, and your extract tadi ke dalam column. Okay, so gas tadi dia akan tolak your samples along the stationary phase which is the capillary column. Then dia akan detect the presence of analytes. So dia akan detector tu akan show the presence of compound or analyte dalam komputer which is the chromatogram lah. Kita akan nampak the presence of your compound, and the presence of compound here, okay, dia adalah based on the boiling point dan juga the polarity of your samples. Okay, dan sampel yang sesuai untuk you run the gas chromatography adalah volatile compound dan juga it is non-polar compound. So this is gas chromatography. Okay, dia ada guna helium gas. Okay, inert gas. Okay, this is the column, coil shape. Detect the presence of an analyte and show on your computer the data. So this will inject your extract. Okay, the readout or the data yang muncul dalam on your screen, okay, is the order of elution. So the components yang akan keluar pada the chromatography paper tu adalah based on order, and the order is according to the boiling point of your the samples lah, pada of the compound. So kalau your sample tu ada this compound, so 4 to 5 compounds, so the first compound yang akan presence adalah compound with low boiling point, and the compound yang terakhir akan you can review adalah the compound with high boiling point. Okay, and they have retention time. Okay, so retention time ada the time of elution lah, yang mana yang akan awal tu adalah pada low boiling point compound. Okay, and the order of elution is based on boiling point again, and also the polarity of your samples, of your compounds. Okay, in your extract. Okay, so based on the polarity and the boiling point of the compound, okay, the compound will eluted and show inside the chromatogram. Usually boiling point yang lagi tinggi akan berada pada paling akhir sekali, like this lah, octane paling akhir, awalnya pentane lah, because it has low boiling point. However, some of the sample dia akan lari daripada order of boiling point ni, because kena follow juga pada polarity, yang mana dia akan kacau the susunan based on polarity. Okay, dia akan kacau susunan juga, tak semestinya based on the boiling point, because of the changes and or because of the polarity, it also affect the susunan, tak semestinya based on boiling point. Okay, Again, in general, they elute in order of increasable point. However, the relative polarity of a compound will cause it to elute out of order. So this is very important, kita run standard. So bila standard kita kata okay, kita nak for example you want to measure lupiol yang kita guna standard, the retention time is at for example 180 seconds kan. So using the standard, kita dapat sample kita run pun ada juga that peak kan. So kita tahu lah okay, our samples or our extract ada the presence of lupiol because sama dengan standard keluar pada 180 seconds. So it is very important okay, untuk kita guna standard. Apa-apa pun kita guna HPLC ke GC ke, memang kena ada standard untuk kita proof that peak tu adalah refer to the specific compound yang kita nak study. Next is gel filtration chromatography. Based on the size, okay, exclusion. So this guna gel, okay, dalam bentuk bead form, okay, and dia ada lubang-lubang, okay, also dia based on also known as molecular sieving, gel permeation, and also SEC, size exclusion chromatography. So some of the samples yang mostly measure are the enzyme, antibody, and also the globular protein. So the main things that you have to control in using the SEC ni, the size exclusion chromatography, is the choice of buffer. So kena tahu buffer yang sesuai untuk you punya samples. So theoretically, okay, resolution, okay, will increase with the column length, okay. So column length also influence, okay, the you punya sample resolution. And types of gel matrix yang ada, matrix gel yang ada dalam the column ni adalah Cephalidex, polyacrylamide beads, and also agarose. So dalam beads tu dia ada pores, okay, each beads tu, okay, yang you pilih Cephalus ke tadi kan, polyacrylamide tu, okay, the gel tu or the beads tadi dia ada pores, dia ada lubang-lubang, okay. So usually when you use this type of chromatography, the okay, tadi so the mobile phase will be the buffer, okay, dia punya stationary phase will be the beads lah, okay. So samples yang melalui this size exclusion chromatography, okay, size yang lebih besar dia akan elute first. Why? Kenapa? Bila besar dia tak akan melalui the pores yang ada pada beads, dia boleh direct through. Tapi kalau size of your samples tu, protein tadi, antibody or enzyme tadi yang kecil, dia akan lalui the pores dalam beads dulu. So dia akan lebih lambat keluar. So again, separation depends on difference in the ability of the molecules to enter the gels tadi. Mana dia ada pore lah pada gel tu yang akan slow the movement of your samples. As solvent moves through the column, okay, solvent, okay, dia akan move along the column. Three possible things that can happen to solute, okay, solute ni ada compound lah, okay, solute in your sample adalah your solutes can run with solvent front, okay, can be washed out quickly or late. Kalau quickly ni bila dia size dia besar, ataupun kalau dia akan lambat bila dia totally absorb onto the gel matrix, dia akan tersekat pada the gel. So very large molecule, okay, dia akan keluar first, okay. However, the small molecule dia akan lalui the gel pores. The small molecule which enter the gel pore move more slowly. So dia akan elutate the sample in order of their size. Lebih rendah size dia, lebih lambat dia keluar. So this is the technique, okay, volume of effluent. The time of yang keluar awal ni adalah large samples, okay, yang keluar akhir sekali ni lambat sikit adalah the small size of your samples lah, okay. This is a bead, okay, yang size kecil dia akan tersekat pada the gel bead. Next is the ion exchange chromatography. Tadi size exclusion based on size of your samples, and this is based on the charge of your samples, okay. And for the stationary phase dia adalah bukan gel tapi ion exchange. Okay, and this process, okay, dia ada melibatkan charges. So the ion exchange resin ni terbagi pada two types, cation dengan anion exchanger. Cation exchanger ni dia charge anode kan cation charge positif, anion charge negatif. Okay, cation charge positif. Okay, di mana dia cation exchanger ni dia akan it will catch the positive charge of your samples. Okay, dan anion exchanger ni dia akan capture the negative charge of your sample yang ada negative charge. Okay, again cation exchanger dia akan capture samples you positive charge of your samples, and anion exchanger the sample with negative charge. So this is the column. Okay, dia ada the stationary phase will be the ion exchanger. So kalau kita ion exchanger tadi dia akan capture positive charge. Awak tengok kat sini, this will be the resin tadi, dia akan capture the positive. So yang akan keluar adalah negative charge. Okay, so negative charge dia akan keluar. Okay, positive charge dia akan bind to the cation exchanger. Example here, okay, negative charge will flow through. Okay, protein negative charge will flow through. Dia akan exclude out from this column. Okay, from this and the positive charge dia akan be captured. Example application of this technique of based on charge is the water softening process, di mana dia akan catch the positive charge of your magnesium and also the calcium ion. So yang akan keluar adalah negative charge of soft water. Okay, next is the anion exchanger. So anion exchanger ni dia akan capture the negative charge. Okay, so dia ada bind to the negative charge, bind to the anion exchanger by reversible electrostatic interaction. So dia yang akan eluted out from this column adalah yang positive charge. Okay, this is the electrostatic. Kan dia kata electrostatic tadi, mana positive charge of cation anion exchanger tadi. Okay, dia akan tarik the negative charge. So yang keluar adalah positive charge of your samples. Okay, anion dia capture yang negative. Alright, so dia akan separate the charge of the amino acid. So yang positive charge of amino acid dia akan exclude first. Finish with the ion exchange chromatography. Next is the affinity chromatography. Okay, it is a biospecific interaction, and dia menggunakan affinity of between the ligand dan juga protein lah. Okay, ligand ni biasanya kita tahu kan pada yang akan bind pada reseptor ke pada protein kan. So ligand ni dia mestilah spesifik, dia ada spesifik interest pada yang mana boleh bind specifically to the specific protein. So tak semua specific protein ada specific ligand untuk dia bind. Okay, dari specific. Okay, when protein, yang kalau kita nak sesuatu protein tu kita tahulah what type of ligand yang perlu, yang sesuai. Okay, and in these samples, okay, for example dia ada mixture of protein, banyak protein, tapi kita nak tahu satu protein yang kita nak, kita tahu kita dah letak dah ligand yang sesuai, yang warna hitam-hitam ni kan. So this warna hitam ni sesuai dengan warna merah lah, the protein warna merah. So when we put the mixture of protein, okay, the ligand ni will bind to the with the red protein. So the protein yang not bind with the ligand, dia akan elute out first lah. Okay, and then After that, to remove the protein yang dah bind kepada ligand tadi, you kena letak another solution of ligand yang soluble, okay, solution of ligand ke dalam the column tadi, okay, dan dia akan keluarkan, okay, the protein yang spesifik yang kita nak. So again, this is affinity chromatography, maksudnya daya tarikan dia kepada sesuatu. So affinity of what? Affinity of between the ligand and also the protein. Okay, so with the addition of more solution of ligand, dia akan tolak, okay, the bound of ligands and protein tadi yang tertinggal pada kolom. So this is an example of affinity chromatography. Okay, the goal is to separate molecules of a particular specific in a mixture such as the blood serum lah. So example, antibody in a serum sample specific for a particular antigenic determinant. So kita dah ada antigen sesuai. Antigen tu adalah the ligand tadi lah. So the ligand tu warna blue, which is the antigen. Antigen ni akan bind to the antibody yang sesuai yang kita nak, which is the red color. So dia ada mixture of protein or mixture of antibodies. So antibody sesuai akan bind pada antigen. So yang tak sesuai dia akan remove ataupun elute out first lah. So then you have to add something to push through the antigen antibody. Okay, step first one adalah you letak you punya antigen, which is the immunoabsorbent, yang mana ada terdiri daripada antigen with blue color, then you add your antibodies yang banyak jenis. We don't know which is compatible or that has high affinity with your antigen kan. So kita tak tahu, let them through, and what will be removed out adalah yang tak compatible lah, yang tak ada affinity with the antigen, dia akan remove. Okay, so in elution step, okay, pada yang tak bind antigen, tak bind pada antibody tak bind pada antigen tu, antibody tu akan dikeluarkan daripada the column lah, okay, menggunakan melalui buffer ataupun you boleh using adhesion agent. So dia akan remove out from the column. Okay, and step number 4, untuk remove, untuk dapatkan the yang bergabung, to elute the antibodies yang mana berjaya bergabung dengan antigen tadi, you have to use the dialysis technique. Okay, example, buffered cell line in order to remove the reagent used for elution. Dia akan keluarkanlah antibody yang mana successfully bind kepada antigen tadi. So the selected antibody yang kita perlu adalah the blue color tadi. So menggunakan kaedah dialysis, berjaya keluarkan the antibody. So this is the conclusion of using chromatography. Okay, di mana you have to focus on the stationary phase and also the mobile phase for each technique. Okay, so type of chromatography ada banyak, about 7: paper, TLC, okay, GC, HPLC, J chromatography, ion exchange, also affinity chromatography. Okay, now finish with the chromatography. Next is spectrometry. What is spectrometry? Spectrometry is a technique or method di mana study the spectroscopy, which is di mana study spectroscopy. What is spectroscopy? Spectroscopy adalah the study of spectra. Okay, spectra yang mana terhasil daripada interaction, okay, between a matter, okay, and the radiated energy. So the spectra ni, okay, the radiated energy ni dia akan produce different colors, okay, according to wavelength. So this wavelength, okay, then dia akan melalui matter of your samples. So what is and this spectroscopy tadi dia akan and the spectrometry tadi, to study spectrometry kita menggunakan a machine known as spectrophotometer. So spectrophotometer ni, okay, dia akan measure the concentration, okay, of your samples, okay, menggunakan kaedah spectrometry tadilah. Okay, di mana the concentration of your samples ni, okay, akan berdasarkan amount of light, okay, yang berjaya diabsorb oleh you punya sample. Okay, kalau you punya sample boleh absorb lebih banyak light, so concentration of your sample akan lebih tinggi. Okay, again, by analyzing the light that passes through the solution, you can identify the particular dissolved substances in solution and how concentrated those substances are. Okay. Okay, now the basic component of spectrophotometer, dia mesti ada light source. Okay, and then dia ada prisma. Okay, or monochromator. The monochromator, okay, and also it has the slit to allow the only amount of light yang boleh lalui the cuvette. Okay, and pastikan you punya sample tu inside the cuvette tu mestilah boleh dilalui oleh the light yang melepasi the slit. Okay, mesti banyak lah, jangan sikit sangat. Okay, pastikan amount of 3 to 3/4 of your cuvette size. Okay, and then after this is sample yang mana you letak dalam cuvette. Okay, then the machine has a detector. Okay, detector to convert energy, okay, into of radiant light energy pergi kepada electrical energy. So then it will detect lah the concentration of your samples and then record it. Okay, the value. How it work, how this spectrophotometer work. Okay, the sample, okay, solution inside the cuvette ni, dia akan absorb the light yang come out from the prisma tadi. Okay, yang lalui slit. Okay, ada opening slit ni, dia ada slit ni kecil je bukaan dia. So dia akan yang light yang melalui the slit ni, dia akan melepasi the cuvette, your solution inside the cuvette. Okay, then the sample will absorb the light. Okay, apa yang telah berjadi absorb tu, dia akan refer to the amount of absorb, okay, of your light of amount of light they absorb by the sample will be related to the concentration of the analyte yang you nak. Okay, so again, this is spectrophotometer, the light, okay, yang melalui prisma. Prisma ada slit, bukaan tu dia akan pergi ke pada you punya sample pada cuvette. Okay, dan berapa banyak yang telah absorb dalam of your samples. Okay, itu dah. Okay, dia akan refer to the concentration of the analyte dalam sample. So here, okay, the light tadi, the radiant energy ni, dia kan ada berdasarkan wavelength lah. So the radiant energy dia akan will be converted to electrical energy, and then dia akan translated in the amount of concentration of your analyte yang nak dibaca. Okay, so the use of spectrophotometer for biological sample untuk semen counting boleh, concentration of protein boleh, okay, and also concentration of compounds pun boleh. Okay, how to do spectrophotometric analysis? First, you have to turn on the spectrophotometer machine. Number 2, you have to clean your cuvette pakai deionized water saja, nak make sure tak ada sisa-sisa sampel yang previously yang tertinggal pada cuvette ni, sebab kita kena pastikan dia kaca dia clear and supaya light tu boleh pass through the cuvette. Okay, then you load your volume of your sample, pastikan 3/4, okay, supaya at least the light yang boleh melepasi pada slit tu boleh capai pada you punya sample. Okay, next, okay, you have to prepare you punya control ataupun kita panggil blank lah. Blank ni hanyalah chemical solvent, yang mana kadang-kadang you can also use the blank ni guna water ke deionized water saja. Okay, blank has only the chemical solvent in which the solute can be analyzed. Solid to be analyzed is dissolved in. Biasanya kita guna blank ni adalah tanpa you punya sample, ataupun kita panggil ataupun kita panggil control lah without you punya sample. Biasanya guna water lah. Kalau you guna nak study antioxidant activity, you guna blank adalah yang mana tak ada treated with antioxidant, tu kita panggil blank. Tapi kalau nak just measure the quantity of amount of inside the extract, kan, nak tahu amount of for example nak tahu amount of quercetin, kan, dalam you punya sample. So blank you adalah you boleh guna water saja. Okay, and then you letak this will be your blender, your water will be your blank, and your sample tu adalah extract lah yang you dah prepare. Okay, so first you kena, after you letak your blank, okay, inside the cuvette, okay, you have to bersihkan lah, wipe, okay, the cuvette outside dia, pastikan tak ada air ke kotoran ke, supaya the light can pass through the cuvette. So next, after that you have to choose the wavelength. For example, you tahu quercetin dia punya wavelength dia adalah berapa. For example, 450 nanometer adalah untuk measure quercetin punya compound kan. So you study dalam artikel kata 450 nanometer. So you set the wavelength at 450 nanometer. So specific wavelength, for example 450 tu adalah yellow color. So the yellow color yang akan pass through the slit, okay. Dan berapa banyak yellow color be absorbed by the samples tadi, so dia akan baca lah concentration of quercetin inside your sample dalam cuvette. Understand? Okay, next you have to after you put the wavelength yang sesuai untuk you punya sample 450 nanometer, you have to calibrate the machine with your blank first lah. You kena tekan set the blank to 0, okay. And then lepas dia dah set kan, letak the blank and set the machine to 0, you boleh remove the blank, and then you ready to test your samples. Next, you letak you punya sample lah yang ada inside the cuvette masuk dalam machine. So waktu tu you measure the amount of quercetin inside the samples. So in conclusion, untuk measure spectrophotometer tadi, first you kena turn on the machine. Second, you kena bersihkan cuvette you, pastikan tak ada sisa-sisa dalam dia. And then you kena letak your samples, okay. Pastikan dia punya amount tu boleh melepasi the slit, okay, yang mana allow the light. Kemudian lepas you letak your sample, you kena ada juga blank, you letak dalam cuvette juga. So you kena blank first, blank letak dalam machine, okay. Pastikan you set the wavelength tu based on wavelength yang you nak measure, yang you study, ikut yang you nak, okay. And then after set the wavelength, okay, dan juga blank dah diletak dalam machine, okay, you then you kena calibrate lah. So dia akan jadikan, dia akan zero kan dia punya machine, and then you keluarkan blank. Lepas tu, lepas you dah zero kan dia punya bacaan, optical density tu akan 0, and then you masukkan you punya sample pula, barulah you read the bacaan of you punya sample. So optical density will come out from the machine, okay, specific for your samples at the specific wavelength. So that is how you use the spectrophotometer. Next is the Beer's law, okay. The Beer's law is applied, okay, dalam spectrophotometer machine lah. So Beer's law ni adalah relationship between the color, okay, from the wavelength tadi, okay, and the concentration of your samples, okay. So Beer's law ni states that the absorption of light, okay, is directly proportional to the emissivity, cell width, and also the concentration. Alright, so this is the Beer's law. Beer's law, this is the formula to calculate the absorbance value, okay, that come up, okay, from the machine. Okay, the formula actually is E times B times C. So what is E? Is the molar absorptivity, the tendency of the compound inside your samples, okay, absorbing the wavelength, okay, absorbing the wavelength. Okay, B is the path length of your cuvette from right to left, the length of your cuvette, and C is the concentration of your X compound in your samples. This is a X here, referring X compounds. Okay, so we want to calculate the absorbance value, okay, we have to multiply the molar absorptivity, the path length, and also the concentration of the compound inside the sample. So because it is a linear equation, to quantitatively measure, okay, the absorbance, okay, have to use this formula, okay. And if the concentration of the compound is high, so the absorbance value will be high. Same with the path length and also the absorptivity, okay, the tendency of the compound to absorb the wavelength. So if these three high, okay, within your samples, okay, the path length high, the concentration of the compound high, and also the absorptivity towards wavelength is so high, so the absorbance value will increase, okay, because it is a linear equation. So where the formula come from? A is equal ABC. Actually, it's come from this first formula. Okay, transmittance equal to light intensity of the solution divided by the light intensity of the solvent. Okay, so yeah, so the formula lead to the calculation of A is equal EBC, and this formula works for monochromatic light, and the compound of X, okay, or compound that presents inside your solution, okay, usually has it has a unique absorptivity, okay, E tadi at different wavelengths, so that the tendency in absorb the wavelength at different the uniqueness of the compound, okay, in absorbing the wavelength is very unique. So that is Beer's law. And quantitatively, okay, if you have standard, okay, to measure your samples concentration, okay, for example, you have a standard of for a flavonoid, for example, okay, one flavonoid known as quercetin, okay. So this quercetin, okay, you know the concentration, you prepare at different concentration from low until high, okay, concentration. So then you measure using the spectrophotometer, okay, and then you get the absorbance value, okay. Then the absorbance value, okay, you do the standard curve, okay, you tabulate, okay. So the standard curve then, or the calibration curve then, will be used, okay, to measure the concentration of your sample. And then you take your sample yang you tak tahu apakah concentration of quercetin dalam your sample kan. Tadi kita dah buat standard curve, and then you want to know, okay, this solution as E yang you prepare ni, you tak tahu concentration of quercetin dalam E sample. So you put your E sample inside the cuvette and you read the absorbance value. So if you get absorbance value of 0.3, okay, so 0.3, okay, the absorbance value 0.3 sama dengan berapa concentration, then you get the value of the concentration of quercetin inside your samples. So that is useful of the spectrophotometer, okay, by having this plot, okay, plotting by having the standard curve. This then will help you to identify the concentration of your sample just by getting the absorbance from the spectrophotometer. So the characteristic of Beer's law plots is that they only read in one wavelength. For example, quercetin tadi you must read dalam one wavelength. Okay, for example tadi 252 nanometer. So you read from the same wavelength, from the low concentration of quercetin standard sampai the high concentration of quercetin standard. Okay, then must you have to plot, okay, your curve, okay, from 0.010, okay, absorbance value. Okay, dan the maximum of absorbance value must be 1, tak ada lebih daripada 1. Okay, absorbance over 1 kira macam not valid of the data, and should be avoided lah. Concentration yang lebih daripada 1 should be avoided, yang memberi absorbance value yang lebih daripada 1 should be avoided. Okay, that's all. So today we finished, okay, learn on the spectroscopy, okay, the Beer's law, okay, and also we finish on the numbers of chromatography that we stopped last week, okay, which are the HPLC, we have GC, we have ionic chromatography, we have gel extraction, okay, and hope that with this from this video help you to understand on the these two, so the spectroscopy and also the chromatographic method for biochemical analysis. Alright, thank you. Assalamualaikum warahmatullahi taala wabarakatuh.